Hello everyone, welcome to Civil Engineering and Stuff. And in this video lecture, we will be continuing our discussion on the topic safe stopping distance. In the previous lecture, we had discussed about the theoretical concept behind the safe stopping distance, and there we had learned that the safe stopping distance is basically a combination of two parameters, that is the lag distance and the braking distance. While your lag distance takes into account the psychological parameter, your braking distance takes into account the distance covered after the brakes has been applied. And the formula for lag distance is 0.278 V into TR, and the formula for braking distance was V square by 2G F plus minus N, where V is in kilometer per hour. Correct, kilometer per hour. So basically in this formula, this V that we have put is in kilometer per hour, and this 0.278 we have discussed in the previous lecture. This, by multiplying this, that is 1000 divided by 3600, we are converting this V in kilometer per hour to meter per second. We have discussed this in previous lecture. Correct. And your TR is basically your reaction time. This is your reaction time that is taken by the driver to react to that situation, and usually it is taken as 2.5 seconds. All right. Then the next parameter, that is the braking distance. Again, V is the kilometer per hour, and so in order to convert this V into meter per second, we have to multiply it by 0.278 whole square, right? G is your acceleration due to gravity, that is 9.8 meter per second square, and F is your longitudinal coefficient of friction, and the value is taken as 0.35. Right? This is the standard value. N is the slope of the road, that is, if the road is flat, then N will be 0. If there is some gradient or the slope that is provided on the road, then depending upon if the vehicle is ascending the gradient or descending the gradient, positive or negative value is taken. We have discussed again in detail about this in the previous lecture. One thing that I missed in the previous lecture was this expression V square by 2G F plus minus N, right? So V square, since we are converting this kilometer per hour into meter per second, so we are multiplying it by 0.278 whole square, and G value is also, we know that is, it is taken as 9.8 meter per second square. So if you are adopting these standard parameters, so the another way of representing this expression is V square by 254 F plus minus N. Okay, this is, if you take this expression, 2 into 9.81 divided by 0.278 whole square, you will get 254. Near about 254 you will get. So instead of going into much of the unit conversion and much of these things, so simply writing 254 will do, right? So the formula can be taken as V square by 254 F plus minus N. Now it should be taken into consideration that here the standard values are adopted, that is 9.8 meter per second and 0.278 if V is given in kilometer per hour. Okay. All right. So this was the oral concept that we had discussed, and we had derived the derivation. We had discussed about the PIV theory in the previous lectures. Now in this lecture, we are simply going to do the numerical. Okay. So without further ado, let us jump into the numericals. All right. So, talking about the numericals, the first question that we have in front of us is this one. We have to calculate the safe stopping distance for a road with a design speed of 50 kilometer per hour. Basically, we have a design speed of 50 kilometer per hour, and we have to find out the safe stopping distance if that road is two-way, two-lane road. If that road is two-way, single-lane road, we have to calculate the horizontal side distance, and we have to find out the intermediate side distance. So these are the parameters that we have to find. All right. So basically, what we have to find is the safe stopping distance. Safe stopping distance. So let's solve the question. So we have seen that the safe stopping distance, the formula is 0.278 V into TR plus V square divided by 254 f plus minus n percentage, right? So this is the formula to find out the stopping side distance. Now if we see what are the given parameters, in the question, what is the value of velocity that is being given to us? The velocity is given as 50 kilometer per hour. So we will take the velocity as 50 kilometer per hour. What is the reaction time that is given to us? If you look into the question, the reaction time we have not been given, right? So as we have discussed in the previous lecture, that usually the reaction time is assumed to be in between 2.5 second to 3 second. So we are going to assume the reaction time to be 2.5 second. This is our assumption. We are taking a standard value of 2.5 second. Okay, so this is through this we can find out now the lag distance. Now talking about these the braking distance, the value of v we have, the gradient or the slope we have not been provided, right? So since it has not been provided, we are will say that it is 0, that is we are moving in a horizontal plane road. Then the f value is, again, if we look into the question, we have not been provided. So f, again, we will take it as a 0.35. Okay, this we had already discussed in the initial lectures when we were discussing about the cross-section element of the road. We have discussed about the lateral coefficient of friction and the longitudinal coefficient of friction, and then we have discussed that the longitudinal coefficient of friction is 0.25, that is the standard value. Okay, so now we can see we have all the data. Okay, so let's put the values uh, in the equation. 0.278, v is 50, reaction time is 2.5, plus v square is 50 square divided by 254 into 0.35. Okay, so this is the value. So if we solve these values, just solve the value and see what is the answer that you are getting. So you will have 34.750 plus 26.601. Okay, so this will come out to be 61.351 meter. Okay, so this is the stopping side distance that we have to find, that is suitable for the road, 61.351 meter. Now taking the case specific scenario, that if the road is two lane road, then in that case the safe stopping distance is same, right? This is SSD only, right? So since it will remain the same, so it will be 61.351 meters. In case of two-way single lane road, then here it becomes twice of SSD. So in that scenario, the safe stopping distance in this scenario will be 2 into 61.351. Okay, solve it and see what is the value that you are getting. See, you have to be with calculator and notebook, right? You should be solving as we move along. Otherwise, merely watching the video is it's waste of time, to be true. Okay, I've been saying in previous videos also, whenever we do the numericals, always sit with notebook and calculator. Solve it and see if I'm doing the calculation right. It will like the understanding will be much better. All right. So this is the SSD that we will get if the case is two-way single lane road. We have to find out the headlight side distance. So we have seen that in case to find out the headlight side distance, this is equals to stopping side distance for the horizontal curve. It will be equal to stopping side distance, which is in this case is 61.351 meter. All right, then to find out the intermediate side distance is twice of SSD. So it will be again twice of 61.351 which is equals to 122.702 meter. You fix your calculator to two decimal place so that you can get a more level like acceptable answer. Okay. So this is the solution for question number one. Okay, I hope this is very easy questions and nothing complicated. Just see the main crux of these safe stopping distance question is, first thing is you should know the standard values, right? You should know what are the standard values and the formula, right? I'll write concept also because without concept you cannot attempt the question. So basically concept should be clear. You should remember the formula. The scope of error in the formula is this is the mean scope of error. You see, V into TR. Suppose here in the question we were already given velocity in meter per second, right? If that was the scenario, then we need not to multiply by 0.278. This is very important. Okay, so understanding the concept and the formula, it is very important. Okay, likewise here also, V square by the formula is V square by 2G F plus minus n percentage, right? If we are already given V in meter per second, then we need not to multiply by 0.278. So this 254 will not come. Okay, so that is the scope of error that you will get. Numericals are very simple, formula based numericals, but the concept and the execution in formula should be, you should remember. Second thing is the standard values. Second thing is the standard values. Okay, this you should know. What are the standard values? Standard values in terms of reaction time, right? Standard values in the form of coefficient of friction, right? So these type of value you should be aware of. Okay. Now let us move to the next question. Right. The next question that we have is that basically there are two cars that are approaching from the opposite direction with a speed of 80 km per hour and 60 km per hour, and assuming a braking efficiency of 50%, and if required we have to assume any other data, we have to calculate the minimum side distance to avoid head-on collision for both the cars. Okay, so basically what the question says, I will just explain the question once. Basically, it says that we have two vehicles, right? We have the vehicle 1 and we have the vehicle 2 that are approaching towards each other, at a different speed. So the velocity of of vehicle 1 is 80 kilometer per hour, and the velocity of vehicle 2 is 60 kilometer per hour. Okay, this is the velocity of this vehicle 2, and they are both are approaching towards each other. So to avoid any head-on collision, what should be the stopping side distance for this scenario? Additional data that has been given to us is that both the vehicles, since it says that the assuming a braking efficiency of 50%, so we are going to assume that both the vehicles have a braking efficiency of 50%, and if required any other data we have to assume. Right, this is the additional information that has been given to us, that the braking efficiency of both the vehicle is 50%. Okay, now so basically what we have is that both the vehicles, since these are approaching each other, so what we have to see is we have to find out this overall stopping side distance for this scenario. So first of all, we have to consider the stopping side distance of vehicle 1. What should be the stopping side distance of the vehicle 1? What should be the stopping side distance of the vehicle number 2? Right? And the overall stopping side distance, will be the summation of both. The overall stopping side distance will be the summation of both. All right. I hope this one is clear, because there will be lag distance and braking distance for V1 also, braking distance, lag distance for V2 also. So that is why you have to assume the overall SSD will be the summation of both. The additional data that has been given to us is that the braking efficiency is 50%. Okay, we'll discuss about it as we move ahead with the question. All right. So let us calculate the SSD1 of the first vehicle, that is given as 0.278, V will be 80 and TR we don't know, correct? For vehicle 2, V square 80 square 254. F we don't know, and since no data regarding the gradient of the road is given, so we'll assume the n to be 0, right? Now TR, as we have seen in the previous question, TR we are going to assume, since we have not been given the value, standard value of 2.5 second we are going to take. Coefficient of friction we have not been given, right? So again, value of 0.35 we are going to take. Now, now you see, the braking efficiency is given as 50%. So on what parameter will it impact, or is it just given to confuse us, right? So if we analyze this, the braking efficiency, will it have any effect in the lag distance parameter? I don't think so. At a speed of 80 kilometer, braking efficiency is 50%. So I don't think it will have any effect on velocity. It won't have any effect on reaction time, because reaction time is dependent upon the behavior of the driver, right? How efficient the driver is. So it won't have any effect on the driver. However, it will affect on the coefficient of friction, because the role of coefficient of friction is to stop the vehicle, right? It provides the resistance. If the brakes were working to 100% of the efficiency, then the coefficient of friction of 0.35 would have been applicable. But now brakes are not fully applied, brakes efficiency is 50%, so the coefficient of friction will basically be reduced. So the coefficient of friction, putting the values 0.278 V 80 TR will be 2.5 plus 80 square 254 into 0.175. Solve it and see what is the value that you are getting. This will be 55.6 plus 143.982. So this will be equals to 199.582 meter. Okay, so that is for SSD 1. Following the same process for SSD 2, so we have 0.278 into V is 60, TR is 2.5, V square 60 square divided by 254 into 0.175. So this will come out to be 41.7 plus 80.990. So total will be 122.690 meter. So this is your SSD 2, this is your SSD 1. So cumulative we will get, so total SSD that we will get will be 322.272 meter. Okay, so this will be the total SSD, 322.272 meter. 322.272 meter. Okay, so I hope the overall concept of the question is clear to you. The only trick was, in this question, the only trick was that we have been given the braking efficiency and we have to know what are the data to be assumed. Okay, so the last question is that we have a car that is moving with a design speed of 80 km per hour with a descending gradient of 2%. So we have to calculate the SSD, we have to assume any suitable data. Okay, now the difference of with the previous question is that now we have been given that the vehicle is descending the gradient. The vehicle is descending the gradient. Now, if you recall, as and when the vehicle is descending the gradient, the role of slope will be negative. Why negative? Negative because now it is contributing towards the reduction in the braking efficiency, correct? So here this stopping side distance will be 0.278 V into TR plus V square by 2G F minus N percentage. V velocity is 80. The given parameter V is 80 kilometer per hour. Reaction time since not given, so we'll assume it as 2.5 seconds. And then F is also not given, so F we will assume again 0.35, and N we have been given, so we'll, since it is a descending gradient, so it will be taken as minus N. Okay, so now what we have to simply do, we have to simply put the values in the formula. 8 into 2.5 plus V square. V square is 80 square divided by 254. F is 0.35 minus 0.02. Okay, so this leg distance is 55.60 meter, and this one is, it will be 76.354 meters. So this will total SSD value will come out to be 131.954 meter. That will be the answer. All right. So simple question, nothing complicated. If we had a scenario where the vehicle was moving up, then it would have been positive because now it would have contributed towards the friction value. Okay, so these are the main type of question that you can see in stopping side distance topic. Okay, so I hope the approach toward the question is clear to you, right? And like I said before, the questions are very easy. The only thing that the source of error is the if the concept is not clear, you don't remember the formula correctly, and the standard values, there is a confusion in the standard values. Okay, so make sure all these you are well versed with all these parameters. Okay, do share your views about this lecture. If the lecture was useful to you, do share your comments. If there is some scope of improvement, do let me know. And thank you for watching. Like the video if it was useful to you, and subscribe the channel if you haven't subscribed. We'll post more lectures on switching topic, and do tell us if there is any topic on which you want me to prepare the lecture. Thank you for watching. Have a nice day.